if you go to GitHub/StungEye, like you were stung in an eye by a bee, and you look at the pinned repositories, you'll see one that's called ActiveRecord without Rails. And we're going to clone it, and we're going to make sure that we're cloning with HTTPS. So you can change that. If it's on SSH, you want to toggle it to HTTPS, and you want to copy and paste that link. You just click that button. And then we're going to go to a folder here, and I'm going to git clone that thing, and I'm just going to shorten it down to ActiveRecord class. All right, and then in VS Code, I'm going to add a folder to the workspace, and I'm just going to pick that folder. So I'm going to go to Ruby and ActiveRecord class and OK. And there it is. Oh, you opened up inside of the wrong folder again. ActiveRecord class. Okay, so this is a pre-written repository to help us work with ActiveRecord. ActiveRecord is the default database abstraction in Rails, and it is an object relational mapper, an ORM. And so it takes a thing that's built on relationships, a SQL database, and it maps it to the world of object orientation. So we can make object-oriented calls into the database by chaining a series of methods that build queries for us. And then we get back to us collections of objects that represent the rows in the database tables that we've been querying. In this folder, there is a file called a gem file. And we're just going to take a peek at that for a second. In a Ruby program, if you see a gem file in the folder with the Ruby code, it is a list of libraries that this code is going to depend upon, libraries that are hosted, in this case, up on rubygems.org. So the source of the libraries is the canonical source for the Ruby community, which is rubygems.org. And then you specify the different gems that you wish to be using. We really only need the second two for what I'm going to do today. The gem that allows us to interact with a SQLite database. And so SQLite is an easy way to work with a database where you actually don't need a database as a service or a server. SQLite stores everything in a single file, and you interact with it just by way of this library, which uses in our case, a system level, so like an OS level way of interacting with SQLite. So in Ubuntu, it's going to be using like a SQLite package that's been installed at the system level. We all installed that when we went through the setup steps for for our WSL. And then it also brings in ActiveRecord, and that's the ActiveRecord gem that is included in Rails, but we've just used it in the context outside of Rails here. So Rails is like a curated collection of gems, and ActiveRecord is one of them. They don't have to be used only within Rails. We can pull them out and use them separately, but we have to do some setup work to do that. Rails is going to do some of that work automatically for us. To get these gems, we have to run a command. And so in our folder, in our ActiveRecord class folder, we need to run bundle install. And so the bundle program parses the gem file, sees the gems that are dependent for this project goes to the source and fetches those gems, but it also fetches all of the gems that those gems depend upon. And then there are gems that those like second generation gems depend upon, and it fetches those, and it crawls a dependency tree and fetches all of the gems that these 3 gems depend upon. And that's dependency management. And we have that at the OS level. So when we were using the apt program in Ubuntu, that's dependency management for OS packages. And then in most programming languages, we have dependency management for libraries. So in PHP, we have Composer. In JavaScript, we have Node, or you can also use Yarn. And in Ruby, we have bundler and gem files. So if we run this, what I described just happened. And from 3 gems, we get 12. So gems multiply. In JavaScript, this is made even more complex by the fact that the JavaScript community likes really, really small tools that do little things. And so JavaScript applications tend to depend on perhaps hundreds of libraries, hundreds of small libraries. A typical Rails program, you might depend on like 20 to 100 gems. And you're using them sort of like Lego pieces to build up your program. Okay, that works. That gives us a new file, a lock file. If we open that gemfile.lock, you can see that it is that dependency tree. It's going to show us all of the things and the things that they depend upon and the versions of those things. And if we were then to commit this lock file into our source repository, we could then open this repo, in 20 years, and it would still work. Without the lock file, it might not, because without the lock file, it'll grab the latest version of all gems. Now, the latest version might have breaking changes in them, right? So it might not work anymore. But if you've got a lock file, it specifies exactly the versions of the libraries that your code depends upon. You put that in the repo, and then anyone at any time can pull it and run it, and there should be no issues. And then if you want to force the issue, if you want to take a repo that has a lock file and incrementally sort of bump the versions of the different gems, you could pass version switches in at the gem file level, and you can sort of upgrade your libraries like that, but one at a time. You probably wouldn't want to try to upgrade all of them at the same time if it's been a few major versions. Because with every major version, you will get breaking changes, and by major version, I mean the leftmost number. Right? So if you want to know more about how these numbers change, you got to look up semver, semantic versioning. And that's the rules behind when the different numbers change. And it's loosely patches that don't affect functionality, potential breaking changes and deprecations, maybe even the addition of new features, and then breaking changes for sure. You can't guarantee that things will work after the major version changes. Okay, so we've got those things in place. There's a ar.rb file, and this does the work that Rails is going to do for us when including ActiveRecord. It loads up all the libraries. So this ar.rb, we're going to require it in our code so that our code always does the following things. It specifies that we're going to be using some gems. These gems were provisioned by Bundler. We want the ActiveRecord gem and the SQLite 3 gem, and we also want the logger library that ships with Ruby. So that's the standard logger. Standard logger is a beer. I always start thinking about beer at like 8:30 in the morning, and that is not a good sign. Models, there's models here, and they're all in this folder, and each one of these models maps to a database table. The database tables are inside of this DB folder in a development.sqlite 3 file. So that is our database, and inside of that database there is a categories table, customers, products, provinces, and I think ghosts, maybe. I put this here for a reason. And then we actually go and establish that database connection. So ActiveRecord base, establish the connection, the adapter is SQLite 3, and the database is located at this file location. And then, given all that, we should now be able to run one of these files and see it work. We should be able to say Ruby ActiveRecord read.rb and have it spit out stuff for us. So it spits out some stuff, the top line being there are 10,676, that should say customers, in my customers table. If that didn't work for you, you'll have to see me after class and we'll figure out why, because it should just be jigged up to function. And we're now going to recreate what's in this file by sort of dipping our toes in interacting with ActiveRecord by doing some CRUD. And so if you think back to WebDev 2, CRUD is an acronym that stands for what? The C is, the R is, the U is, and the D is delete. So create, read, update, delete. I like to say, instead of delete, destroy. This sounds so much more metal. So that's what we're going to look at, but today we're only going to look at the read because that's the easy one, right? That's what's going to be doing the equivalent of SQL select statements. And so let's make a new file in here. So I'm going to touch a new file, and it is, I'm going to read customers read.rb. And I'm going to open that up inside of VS Code. Okay. You saw in the ar.rb file that I'm pulling in libraries with require. I can also pull in local files with require relative. And so I can say require relative ar.rb. I think the .rb is not even necessary. Let's see if we can take it off in a second. I should be able to just run this without any error again. So all this will do by having ar.rb in it, it'll run through this set of stuff. It'll bring in the libraries, it'll load up the models, and it'll make the database connection, but then it's just going to leave the program. And so I didn't see any errors, so I'm going to take that as a positive, that things are working. Let's see if I can leave off that .rb. I think I can. Yeah. Require R. We're writing pirate code today. SQL pirates. So the very first thing you learn in SQL that's actually a SQL statement is usually a select star from database table. That's sort of like the hello world of SQL. So if we were to get all the customers from this table, we would do a select star from customers as our SQL query. Another thing that might be a hello world for SQL, although it's slightly more complicated, is the account star from customers. So this is going to fetch all the customers, and you don't need to write this because all of this is in, there's an equivalent file in here for everything that I'm going to do, which is just the final version of all these files. So you can write the code, but don't worry about writing the comments necessarily unless you're very fast at typing, because they're all in here. And this is going to fetch the count of all, or fetch the number of rows in the customers table. I type things out because it helps me slow down a little bit when I'm in front of the class. So let's do both of those things using some ActiveRecord. And this is the first glimpse of magic. there's going to be a magical way to connect to the customers table done by way of file naming conventions and class naming conventions. So one of the files that's being pulled in by ar.rb, it's just another Ruby file, is this one right here. The others aren't actually needed at this point in time. So like this could be gone, this could be gone, this could be gone, this could be gone. This is the one we're working with, model/customer. And if we go to it, there it is. I'm even going to remove most of its content. So I'm going to remove everything inside of there to the point where we have this class called customer, which inherits from ActiveRecord base. ActiveRecord is the ActiveRecord gem that we brought in with that gem file, and it is a module that contains a number of classes, and we want a class called base. And so this is the resolution operator. It lets us fetch constants from modules, and every class is a constant in Ruby, so we're fetching the base class from the ActiveRecord module, and that's going to give us access to that customers table by convention. So the convention here is the associated table is the class name, lowercased, and capitalized. No, and pluralized. That'd be weird if it was lowercase and then capitalized. Pluralized. So for us, that's customer goes to customers. Lower, is that one word, lowercased? Or is it like a thing like that? That looks better, lowercased and pluralized. We don't do anything beyond naming convention. Things would break if we typoed this though, right? If I wrote like customer, Rails is now, or ActiveRecord is now going to try to look for a customer table, and it's not going to be there, and nothing in my tooling is going to tell me that I've made a mistake, right? So that's again a problem or a potential downside to the flexibility of a language that is very dynamic. And so again, Ruby programmers sort of paper over that problem with tests. And so sometimes Ruby programmers lean on tests because they don't have a compiler and they can make typos like that. Okay, customer. And so now we're going to go over to this file and we're going to use that class, and we're going to use a bunch of inherited methods from ActiveRecord base that are class level methods that are going to return collections of customer objects where each customer object represents a row in the customers table. So each customer object we interact with represents a row in the customers table. We can query for these objects using class level methods on the customer class inherited by ActiveRecord base. Okay, let's do that. Let's use a class level method on the customer class to retrieve some objects of type customer. If I want to get all of the customers from the customers table, I will say customers equals. This is just a plain old variable. I could name it anything I wanted. I'm going to the customer object and I'm going to fetch them all. And that is going to write for me select star from customers. If I want the number of customers, I could go to that customers collection and ask for its count. Size works as well. you can just choose which one you may want to use. I choose to use size because that's consistent with other Ruby collections. Some programmers want to use count because that matches the SQL domain more. And then I can put, so there are number of customers in the customers table, or just in the database. I'll show you in a moment. Like, what type is it, are you wondering? Or let's run this and then we'll expect what sort of comes back to us along the way, because that is a very good question. Like, what is that thing? And again, this is the downside of a dynamic language, because in another language we would know based on its type, right? The type signature of the method call would tell us what it's returning. So let's again run that customers read. And we see that the same thing we got prior in the pre-written program. There are 10,676 customers in the database. So before we inspect the types of those things, let's just look to see at the SQL that ActiveRecord is writing for us. When we looked at the file, we were thinking that, okay, this is a select star from customers, and this is a select count star from customers. We can see the generated SQL if we go into ar.rb, and there was a reason why we were bringing in this logger, and the reason is that ActiveRecord base can be assigned a logger, and we can assign to it the Ruby standard logger and have it output to standard out, which is a very sort of Unixy thing to do, right? So targeting standard error or standard out. In this case, the logger targets standard out. And that just means the terminal. Standard out is just going to print out along with our program. And so if we now run the program, we can see that there are two queries being triggered. One is probably happening at connection time, so this would probably happen only once per file or once per program. It's that we're querying the SQLite version from the SQLite database, and that probably informs the ActiveRecord adapter that connects to SQLite. And then we're doing a select count star from customers to get the size of that table or the length of that table, and that's what we expected. But interestingly enough, it didn't bother to run this query for us because we never actually used that data. And so ActiveRecord is lazy in the best possible way, right? Lazy execution of the SQL. It's not going to try to build and execute a SQL statement that you aren't actually using the data for. And so the program knows that you need the size because you print it out, but you never actually use the customers collection except for when querying the size. And so what is customers? It is an abstraction. It is going to be an object of type, I think, ActiveRecord relation. So let's put that out. Customers.class. No, I don't want to define a class. So what we got back was a ActiveRecord relation, which is a class within the customer. So where it's sort of, it's been assigned as a class constant on the customer that we're working with. It's under the hood, it's using another library, and that library is called, I don't know how to pronounce it. I've only seen it written down. It's like Arial, but spelled strangely, or Aryl maybe. And what it is it's mathematical set theory that maps to SQL. And so it's a way of, when we sort of chain a bunch of ActiveRecord methods together, it's going to keep a data structure that represents the set theory behind what needs to be queried from the database. And that can be optimized and spit out as SQL at any given time. And so that's nifty, because that allows for this like delayed execution of SQL until the moment that we actually need it. And so if we need it, like say down below here, I go to my customers and I say each of them, I should get the customer, and puts out the customers, and we should have a name. And so when I key into an object of type customer, I should be able to key into the columns of the customers table. And now we need that collection. I don't really want 10,000 right now. And so I'm going to limit on like just 10. And what that's going to do to my SQL statement is just that. It's going to add the limit 10. And I could do .all.limit, but the .all is no longer required because this will build a relation as well. And so if I run this now, my output's a little bit incorrect. There's not 10 customers in the database. There's 10 customers in the relation that I'm working with. So there are 10 customers in the current relation. And then I loop through them by doing it each on and grabbing each one's name. You can see here they are, Christopher Hartman and Donovan Guthrie. And if we look here, we're now doing multiple SQL statements. We're doing the one that's counting the collection, and then we're doing the one that's actually gathering with a parameterized limit clause, and the limit is assigned to 10. And so that's the really quick intro. Before you go, I'll just show you one last thing, which is the next thing you usually learn in a SQL class, which is a where clause, right? You want some kind of subset of the database table and not just a limited set of all the rows, but like a specific subset. And so we can say Winnipeggers equals customer.where city is Winnipeg. I use city again because I know the structure of this database. I know that there's a city column in there. If I wanted to know what all of the columns look like, I could grab one of these Winnipeggers and grab the first one and prints out the inspection of it. And that's going to show me all the instance variables inside of that object. And then I will also put out there are Winnipeggers in the database. So this is going to print out, or this is going to formulate a relation that looks like select star from customers where city equals Winnipeg. So let me just run that for you. Oh, that needs to be dot size. There are 54 Winnipeggers in the database, and one of those Winnipeggers is Ashley Alvarado. And you can see there the city is set to Winnipeg. And we can also see all of the other properties of a customer. And notice we don't have any of those properties defined within our customer class. They're all being inferred by ActiveRecord by way of it inspecting the database table. So ActiveRecord is going to infer the properties of a customer by reflecting on what is in the database, and that is that there is a primary key called ID, a name, an address, a city, a country, a postal code, an email address, something that looks like a foreign key, a province ID, and a created at and updated at timestamp. And so that's the final piece of the puzzle that we're going to look at today, is that's what a customer object looks like. You saw me interact with it in terms of it acting or looking like a hash, but it's actually a hash with indifferent access. And what that means is that if I want to, and I usually do, I can access it as if it is an object that has a name property, and so that will still print out all of those names above here when we query the individual customer objects. And so that was our very high-level initial look at ActiveRecord. It's an abstraction. It's abstracting over SQL. It's doing that by way of building set theory relationships under the hood that represent what we are querying, and we can even like chain things onto it. Like I only want 5 Winnipeggers, and now it will, chain that onto us. I can chain on a .order to order things, and it will, add an order by clause. And yeah, magic is sometimes awesome. And so this is the first little bit of magic that Rails has to offer for us, an abstraction over SQL, giving us an ORM, an Object Relational Mapper. Thank you very much for coming to class on an early morning on Friday when it was raining out, but I love the sound of rain, and so I hope you like it too.